Hi, this is Mrs. Han. I'm going to go over this activity seasons for those of you who need a little bit of help. What I would do is I would go ahead and click here and pop that open, and then go ahead and open it with Cami so you can write on the document. Do not open it with Google Docs because that will change the formatting and it becomes strange. Then go ahead and click on this, and this will launch. This will open up this page, and then you're going to go ahead and click on Launch, and that will open up this page. So let's go ahead and have both open. In this activity, you're going to learn about seasons, why it tends to be warmer in the summer and colder in the winter. You might know this already, but this is kind of an interesting interactive, and it's going to add to your knowledge about the Earth, the Sun, and the Moon. So far you guys learned about the Sun and the Earth, how the Sun is revolving. The Earth is revolving around the Sun, and the Earth is rotating, and that's what's causing us to look like the Sun is rising and falling. And now we're going to see why we have warmer summers and colder winters in the United States. So let's take a look. It says to keep the setting on New York and press the small blue circles around the Earth's orbit to observe how the sun's angle and path in the sky change. Okay, so let's take a look. Here we have New York, and here we have these little blue circles. Sorry about that, my dogs. So as you click on these blue circles, you can see the Earth is rotating around the sun. And we can see that in December, it seems to be, and another thing we notice is that the Earth is not straight up and down. It's kind of on this imaginary pole or axis, and that pole is tilted so that the North Pole is actually a little bit away from the sun in December. And then as we move around toward June, the axis is staying in the same tilt, but by June, we're actually tilted. The North Pole is more tilted toward the sun. So in December, we're sort of tilted away from the sun. And if you look at these pictures down here, you can see that as we're away from the sun's angle is a little less direct. And so we are going to experience winter, fewer hours of daylight. Here's the path of the sun in the sky. It's not that we're farther away from the sun. We're actually in our orbit. We're actually closer in December, but we're angled away. And so the sun's rays are not as direct, so we experience colder temperatures. But if you look at Australia, the South Pole is actually closer to the sun in December. And so they are actually, you can see here's the angle at noon. So they're experiencing their summertime in December, which is kind of strange for us to think about. And in June, they are experiencing winter. So let's go ahead back to New York and let's look at some of these questions. Does the Earth stay in one place throughout the year? Well, hopefully you've been able to see that as it goes through the months, it's making a rotation around the sun. So it's not staying in place. And it's not only going around the sun, but hopefully you remember that every day it's turning around once. So it's making a revolution for day and night, and it's making a bigger revolution around the sun for a year. So actually, this is not a revolution. This would be called rotating, and then this would be making a revolution. Okay, number 2 and 3 is asking questions about the angle of the sun at noon and how they change through the year. Okay, and how that creates the seasons. So hopefully you can explain in December how the angle of the sun is not as direct as in June. So it's creating warmer temperatures when it's right overhead, more overhead, and more direct because of the northern hemisphere pointing more directly to the sun. And in December, the North Pole is pointing away from the sun, and so we're getting less direct sunlight. If you notice, the middle of the sun seems to always be getting some direct rays, so the middle of the sun is hot all the time. And that's kind of, they don't really get winter, they're always in summer. And then what do you notice about the angle of the Earth? Well, you can see that the Earth is sort of tilted on its axis, and that causes the northern hemisphere to have a different position than the southern hemisphere, and so that's going to cause them to experience direct rays or indirect rays at different times. So the southern hemisphere is going to be pointed away, so their temperature is going to be opposite of what the northern hemisphere is experiencing. Okay, I hope that's helpful to you. And then go ahead and after you answer the questions, you're going to kind of put your final summary observations about what you learned from this activity about the sun and the earth. We didn't do the moon in here, so you'll just mention what you learned about the sun and the earth through this model. If you have any other questions, feel free to send me an email.